Hello everyone. Today is April, and let me check that date again. Today is April what? Today is April 6th, so we're on Monday. So hope you had a good weekend, everybody. I'm working away here. It's like 6 o'clock at night at OCC, and there's two of us here working in the building. So trying to get as many of these lectures up for everybody. So let's look. That brings us to 9.8. And we're looking at simplifying expressions. The rule for us and everyone else is you can combine only like terms. Okay? So it's our job now to determine what is a like term, and indeed what is a term as well. So let's look at what like terms are. If we have 3x and we have 5x, these are like. If we have 2y squared minus 1/2 y squared plus 17y squared, these are like. Because those are x's to the 1, these are all y squareds. These are all like. So then what is unlike? Unlike would be 3x plus 7y. X and y are not the same, so these are unlike terms. Let's look at combining them. And I am looking on page 666, and I'm looking at 1a, and we have 9k plus 12 minus 5. The only like terms would be the numbers here, and so 12 minus 5 is 7. We cannot do anything with the k. Looking at number b here, we have 7 left paren, 3p plus 2q. I'm going to distribute. I get 21p plus 7 times 2q, and that's going to give me 21p plus 14q. Can I combine? And the answer is no, because p and q are unlike terms. So we need to know what the difference is in some vocabulary words. We need to know what a term is and what a factor is. So let's look. Terms are separated by plus and minus signs. For example, 3x squared plus 2y squared. 3x squared, this is one term. 2y squared is another term. We cannot combine them because they're unlike. Factors are multiplied. Example, 2xy cubed. We have 2 times x times y cubed. One factor, another factor, 3 factors here. Let's look. On page 667, we want to identify like or unlike. and we're looking at 3b. We have minus 8y cubed, and we have 12y squared. This has a 3, this has a 2. They are not like. Look at D. We have 7x squared y to the 4. We have minus 7x squared y to the 4. These are like because they're exactly the same. So it's very important to recognize what's like and what's unlike, and it's very important to know the difference between terms and factors. So get used to that vocabulary there. On page 669, number B is a little bit harder, so let's start with, C is hard as well. All of those have a lot of minus signs to distribute. So let's start with A then, where we have 10p plus 3 left paren 5 plus 2p. Okay? So the directions say simplify. 10p plus 3 times 5 plus 3 times 2p. And that gives me 10p plus 15 plus 6p. I have to recognize what's like. The 10p and the 6p are like, giving me 16p plus 15. Now B is a problem that you're going to see in several math levels because it's a little bit trickier. You have a choice. You can think of this as being a 1 here, and then that would be minus 1 times 1, and then minus 1 times z. 7z minus 2 minus 1 minus z. If you choose, you can put the like terms next to each other so that you get 6z here, and you're pretty proficient at this, and now you've got minus 3. Also, I'm a big proponent of the word opposite, and I would have 7z minus 2. I would say the opposite of 1 is negative 1. The opposite of z is negative z. And that would still give me 6z minus 3. Do you have to show all these steps? You do not. But for those of you that have never added like terms, my suggestion is do not skip steps at all. Looking at the homework 9.8 is that skipping down to number 42, the question is we have 9.8, 42. The question is we have 7, 17, and minus 83. Are these like? Yes, they are. They are like terms. But if you look at 44, we have T and S. They are unlike. I think that that just jumps out at you, and you would have no trouble determining that. The ones with the exponents you have to be quite a bit more careful with. Look at problem number 48. 48, we have minus 4z minus 8z. This is the same as combining sign numbers. Minus 4z. I'm going to change the sign here of the subtrahend. I'm going to change it from positive to negative. I'm going to change the minus sign to plus. And now we have minus 4z minus 8z. I have 12z. Take the given sign, and we get minus 12z. So before we were just adding the numbers without the variable. Now we have the variable involved as well. looking at number 54, I have r minus 6 minus 12r minus 4 plus 16. I definitely would put the like terms together, minus 6 minus 4 plus 16. So these are like, and that gives me r plus a negative 12r minus 11r. Here I'm going to get minus 10 plus 16. I think that we've done so many of those that I was allowed to not do every single step there. Looking at problem 64, we have 4 left paren, 6y plus 9 plus 7, and what we need to do to simplify, we need 4 times 6y plus 4 times 9 plus 7. 24y plus 36 plus 7. Add these, we get 43. I cannot go any further on that. I think I'm going to drop back, and I'm going to do something like problem number 62 for this reason, is where students get confused is when we have many exponents. So I would put the like terms next to each other. This one and this one have a 4 exponent, and this one and this one have a 6 exponent. So when I add these, they're like, and I get 21x to the 4. Do not change the exponent. We have to keep it like. Here we have 14x to the 6 minus 7x to the 6 gives us positive 7x to the 6 here. Okay, so you want to look at everything carefully. I would put the like terms next to each other and designate them so that you know how to do them. Looking at let's say that we want to do number 72, 5x plus 3 left paren. I'm going to get 5x plus 3 times 7 plus 3 times minus 2x. So here we have a positive 21 minus 6x. These are like 5x minus 6x plus 21, and we're going to get minus x plus 21 here. Okay? In this group, please omit page 671, omit problems 61 through 64. You are not responsible for those problems at all. And we're probably going to just go down to maybe 70, 75 at most, okay? So we're probably just going to do something like 5 through 75, the odd, omit these here. We're not going to do all those fractions. Those are great things that you can do in math, 1100 and 1150. So let's look at 74. Even 74 is totally a Math 10 1100 problem, not just a 1050 problem. So in order to simplify, I'm going to distribute, and it looks like this. I'm going to distribute and do that. So now I get minus 6t minus 12 plus 16t minus 32. Let's put the like terms next to each other. So this will be 16t minus 6t, and that gives me 10t because they are like. And now I have minus 12 and minus 32. They are like. I get like signs. So we get 44. I use the given sign. So this would be the upper end of this page. You're going to go to 75, and that is sufficient for us. That's a pretty lengthy assignment for you. And this is strictly algebra now. You're into strictly algebra. This brings us to chapter 10. So let's look at 10.1. Addition property of equality. So you don't have to know that name at all. I'm not going to be testing you on that name, but you need to know what it says. If you are given A equals B, and we add some number C to each side, we have maintained a balance on the teeter-totter. In other words, this C and this C are the same, so it is still equal here. Let's look on page 687. I am looking at 1b, and we have x minus 25 equals minus 18. The question says for us to solve this. So just like when we were doing the Pythagorean theorem, we want this x to stand alone. The opposite of minus 25 is plus 25. So these add out. 25 minus 18 is going to give me 7. We're going to check to see if our answer is correct. Always go back to the original equation. Substitute in your 7. Is that true? 7 plus a minus 25, does that equal minus 18? Yes, indeed it does check. So I mean, the decimals and the fractions are totally possible, but I'm not going to hit you hard on things like that. Look on page 688 at 3b. 22 equals minus 16 plus r. We want the r to stand alone, so I'm going to add 16 to each side, and that gives me r equal to 38. For A, 11z minus 9 equal to 12z, I need to get the z's all on one side. So the opposite of positive is negative. That will give me a 0. And 12 minus 11 is 1z. Z equals minus 9. 4b looks as if it should be easy, but you need to think about this. Is we want the solution. We never want minus x. We always want positive x. So I have to multiply the left-hand side by minus 1 and the right-hand side by minus 1. And that's going to give me a positive x. 6 times minus 1 is minus 6. Well, I haven't even done the multiplication property of equality, but in order to solve this problem, yes, I did that and I showed you. So that will be in the next section for sure. Let's look. Page 690. We're looking at 9r. We have 9r plus 4r plus 6 minus 2 equals 9r plus 4 plus 3r. Okay? This is a plus sign here. So have your books open when you're watching this. So this gives us 13r. 6 minus 2 is 4. So on the right-hand side, we have 9 plus 3 is 12r plus 4. So now I want the r's on the same side, so I'm going to subtract 12r from each side, and now I have 1r plus 4 equals 4. The r needs to stand alone, so the opposite of 4 is take away 4. Now we get r equal to 0. Let's do a check. When you do your check, you must go back to the original equation. So I'm going to put in a 0 plus 0 plus 6 minus 2. I'm going to put in a 0 plus 4 plus 0, and we get 4 equal to 4. Yep, we did it correctly for sure. Okay? So now, looking in our problem set, I am on page 691, and we're just going to start out and do basic, and we have x minus 8 equal to 9. I want the opposite of minus, so I will add, and I get x equal to 17. Looking at, once again, I'm not going to be hitting you a lot with decimals at all. Let's look at 16 here. X plus 45 equal to 24. Okay, class, what is the opposite of plus here? To get rid of it, I have to subtract. So I'm going to get an x. I have minus 45 plus 24. I have minus 21. Okay? So you're going to do the opposite of what the sign is. I will have you omitting some of these problems in the middle of the exercise. Some of them you can do, and some of them you aren't going to do. I'm not going to have you do some of them. So looking on down, let's look at number 28. Sometimes this confuses students to have the variable on the right-hand side. It doesn't make any difference. We're going to subtract 17, and we get z equal to minus 14. Forward, 38, 5x equals 4x plus 9. We want the x's on the same side, so I'm going to subtract 4x, and we get x equal to 9. Notice here I subtracted numbers, here I subtracted numbers, but here I had to subtract the variable in order to get all the x's on each side, on the same side. Looking at something like 50, we have 8x plus 4 equals minus 6 plus 7x. So I need the x's on one side and I need the numbers on the other. It makes no difference. I'm going to subtract the 7x from each side, and that gives me x plus 4 equals minus 6. This added out, I now have to take the 4 to the right-hand side, and that becomes x equal to minus 10. Remember, we add 6 and 4, we use the given sign. Keep saying the rule to yourself so that you are familiar with that. I see that there are a lot of questions on this page that would be more appropriate for Math 1100. So you're probably going to omit from probably, we're going to omit 61 through 64. I think we're going to do number 65 and do number 67. Do those two, and then we'll omit the rest. Okay? So these two we need to do. Okay? The rest of them are totally in Math 1100 and 1150 questions to do that. So let's do 66, and that will help you out with 65 and 67. So here I'm going to distribute 2 times 3x plus 2 times negative 4 minus 5x equal to 7. 6x minus 8 minus 5x equal to 7. These are my like terms. 6 minus 5 is 1x. I need to get the x to stand alone, and that gives me x equal to 15. That should be a good, large amount of problems for you for that section. Okay, so I mentioned the multiplication property of equality. And that is exactly what it says. If we multiply each side by the same quantity, we have not altered the value. So given we have an equation A equals B, if I multiply the left-hand side by C, I have to multiply the right-hand side by C. So that's what this says. Multiply each side by the same value, and we have not altered the value of the equation at all. Looking on page 694, we're looking at B here, and we have 3r equal to minus 12. So we need 1r. So in order to get 1r, I can multiply 3 by its reciprocal, which is 1/3. And if I multiply the left by 1/3, I have to multiply the right by 1/3. So the 3's cancel. 3 goes into minus 12, minus 4. We get r equal to negative 4. So some of you might be saying, why are you doing it using a reciprocal? I would just divide by 3. Absolutely. Multiplication and division go together. We would get r equals minus 4, and this is the way I would do it as well. This way sticks with that word multiply, but this could easily be multiplication and division property of equality. This is much easier on the right-hand side. So continuing on, we're looking at something like 3a where we have 2m equal to 15. I want 1m, so I divide the left by 2 and the right by 2, and I get 15 halves. You can write it as 15 halves. I see that your author uses set notation. Prior to this section, I did not see set notation, so I probably wouldn't require it unless the directions said that, and it does not say that at all. Okay? Looking at C, we have 10z equals minus 45. I'm going to divide each side by 10. We get z equals minus 45 over 10. I ask myself, am I done? I know that each of these will divide by 5. So we get minus 9 over 2, and we're going to leave it that way. Remember, mixed numbers are useless unless we're doing story problems and we want to answer something like how many, yards of whatever lace or material that we want to buy, how many gallons of paint. Then of course we're going to answer it in a mixed number. But in problems that aren't involved like that, we do improper or proper fractions, whichever way it comes out. Looking at number 4, is that here we have minus 0.7m equals negative 5.04. We want to divide by negative 0.7, and that gives us m equals 2 negatives is a positive, everybody. 0.7 into 5.04. Move the decimal one place. 7, 49, 14, and we get m equals 7.2. There's 2 parts to your answer, the sign and the number. The sign and the number. Looking at 5a, x over 5 equal to 5, we need 1x. So in order to get rid of this, I'm going to multiply each side by 5, and we get x equal to 25. Here's one that is quite different. Let's look at 6a. 6a. This is a little bit more involved. We have signs, we have a fraction, and our variable, of course. So we want 1t. In order to get 1t, we have to multiply by the reciprocal. So the reciprocal would be flip it over, minus 6 over 5. And if I multiply the left-hand side by minus 6/5, I have to multiply the right-hand side by that as well. So these are going to cancel. 2 negatives is a positive. Over here, 5 goes into 15/3. 2 negatives is a positive, and I get plus 18. If you do not like using reciprocals, you can do the 2-step method. That would be step 1, multiply by 6. So then the 6's cancel, and I get minus 90. And then step 2, divide by 5. Oh, actually negative 5. And that will give me t equal to 5 into 90 has to be 18, positive 18. There's nothing the matter with this 2-step method. And in fact, for a lot of people, it is clear. So feel free to use that method for sure. Looking at number 8, we have 7m minus 5m equals minus 12. So these are like. I can combine them. 2m equals minus 12. I'm going to divide each side by 2, and I get m equal to negative 6. Let's look at our problem set. You can see that this author loves to give a lot of problems. Every problem set, we're pushing, 80 problems. But I'm asking you to do the odd only, and then on some of the problem sets, we do skip some of the sections, some of the problems, excuse me. Looking on page 698, we're going to start up with something like 24, and we have 3m equal to 10. We want 1m, so we'll divide each side by 3, and we get m equal to 10/3. We're just going to leave it that way. We don't want decimals. It would not be exact. We want it exactly the way you see that. 28, 4s equal to negative 34. Divide each side by 4, and I have s equal to negative. These are even. I'm going to get minus 17 over 2. Look at, as I said, he loves decimals. Minus 3.9a equals 31.2. We're going to divide each side by negative 3.9. We have opposite signs, so we know the answer is negative. So divide 3.9 into 31.2. Move your decimal one place. It does not go into 31. And look, I would try 9. 9 is going to be too big. Try 8. 72 carry 7. The answer is negative 8. Okay? Let's see where we're going. 46. 3/8x equal to 9. I don't have you in here to ask if you want method 1 or method 2. I'm not opposed to doing 2 steps. The 8's cancel, and I get 72. I want 1x, divide by 3, and 3 into 72 goes 2, 4. 24 times for that. You also had the option of, or you could have multiplied by 8 over 3, 8 over 3. What am I doing? Yep, 8 over 3. Then the 8's and the 3's, that's the one-step approach. For some people, for many people, this is the easier method. I prefer that myself. I'm not big on reciprocals. It's up to you. I wish you were here to tell me which way you liked it, and then I could do the problems that way. Looking on down at 56, 11r minus 5r plus 6r equals 168. Well, we can't solve this at all until we add all of these. 6r plus 6r equals 168. That gives us 12r equals 168. I need one of them. Divide by 12, and I have r is 12 into 168, and I get 14. Okay? So you need to simplify first. All the variables must be on one side before you can possibly solve. 52, 9p minus 13p equals 24. I have to combine these, so I have minus 13 plus 9 gives me minus 4p equal to 24. We want 1p. Divide each side by negative 4, and we get negative 6 here. Okay? Looking at, let's choose one that has a parenthesis. Let's choose 62, 5, left paren, and I need 3x plus 2 minus 10 equal to 30. Distribute 15x plus 10 minus 10 equal to 30. The 10s add out. 15x equal to 30. We need 1x. Divide each side by 15, and we get x equal to 2. On this page, for sure, I will be omitting a few of them. Probably we're going to, something like 63 might be an extra credit. We're going to omit 64 to 68 for sure. And there's a lot of word problems here, expressions, that we won't do either. I can get back to you on that. So a couple we can do, but not all of them. Number 70. A number is multiplied by 4. So a number multiplied by 4 would be 4x. The result is 6. Equal sign is the same as the word result. And then when I divide each side by 4, I get 3/2. It reduces to that. Okay? We're moving along here, a lot of algebra in a short time. Looking at 10.3, solving more linear equations. Solve more linear equations. Okay? So to solve, step number 1, you want to simplify each side. Number 2, isolate the variable term on one side. Isolate variable and check your answer. Okay, so we only checked one so far, 2 maybe. You don't have to check every single one, but I suggest that you check maybe like 4 of them in this section. And this is a pretty challenging section, is 10.3. So let's look here, and I'm going to start with number 14. Well, maybe I'm going to start with something else. Hold on here. Something a little easier. And also, some of it is duplicated, but we could start with page 701, and I'm going to look at 3b here, okay? And on 3b, we have 2q plus 3 equals 4q minus 9. So absolutely we have to mind our P's and Q's, but here we just have Q's. So it makes no difference what you do first. You can take the Q's to the left, you can take the Q's to the right. I have students who always want a positive variable, so they would take the 2 to the right-hand side. I probably always take it to the left, but you may go to either side. So step number 1, I'm going to subtract 3 from each side, and I have 2q equals 4q minus 12. I will now subtract 4q from each side, and now I have 2 minus 4 minus 4q plus 2q. Find the absolute difference. Use the sign of the larger absolute value. Divide each side by a negative 2. Both are negative. We get 6. So the author told me to check. You always use the original. So 2 times 6 plus 3. Does that equal 4 times 6 minus 9? 12 plus 3 equals 24 minus 9. 15 equals 15. Yes. As I said, check a good maybe 4 of them in this problem set so that you can see how to do the check. I will ask you to check at least one on the exam. I will say show the check. Show the check. And some of these in here are really harder than they need to be for Math 1050 for sure. So let's just look here. I wish that I could just give you a problem to do because I need to check my notes for one thing. So I'm going to start down here with problem number 14. Let me just, excuse me 1 minute while I check my notes to make sure I'm not doing too much that I need to do. Sorry about that, folks. I just wanted to make sure I'm not off my chart here. But no, this is section 10.3, and it's all included. There is nothing omitted on 10.3. I just thought possibly some of the problems are a little bit challenging that the department omitted them. But I do not see that on the chart there. So let's look. This would be a typical Math 1050 question here. This is perfectly fair. I'm going to isolate the W. So I have minus 7W equals 14. I need one of them. I'm going to divide by negative 7, both sides, and I get W equals minus 2. We need a sign and we need a number. So this is a perfect 1050 question here. Looking at something like number 18, this is perfect. 4r plus 2 equals r minus 6. I'm going to take the r's to the left, the numbers to the right. So I'm going to subtract 2 from each side. I have 4r equals r minus 8. Subtract 1r, and that gives me 3r equals negative 8. We always need 1r. So I will divide each side by 3, and I get r equal to minus 8/3. Now, all of these problems can get more challenging. They can have parentheses in them. They can have more involved with combining like terms, such as 22. 9p minus 4p plus 6 equals 7p minus p. We can't solve any of these problems until we combine terms. So this gives us 5p plus 6 and 7. This is actually a 1. So 7 minus 1 is 6p here. I want all the p's on one side. So in this case, I see if I subtract 5p from each side, I'm going to get 1p, and out comes my answer. So that made it just like one step easier if I did it in that order like that. Let's look at something with parentheses. Some of them are easier than others. For example, right now, I see for you to, on page 709, I see for you to omit question like 29, even 25, 25 and 29. I'm not going to ask you to solve anything with that opposite when it's so involved. I'm not saying I don't want you to do opposite, but there's just too much going on there. But 27 is a very good question. So you want to do 27. I will do 28, and then you can compare it to 27. 5 left paren minus 4m equals 8m plus 27. I'm going to distribute 5 times 2m plus 5 times 3 minus 4m equals 8m plus 27. 10m plus 15 minus 4m equals 8m plus 27. These are my like terms. You can put them next to each other if you want. 10 minus 4 is 6m. So we did all these steps just to get to this point here. You have to get rid of parentheses. You have to combine like terms. So now I have 6m equals 8m plus 12. I have to get the m's to the left-hand side. 6 minus 8 is negative 2. So you can write over on the side if you're still, having trouble with adding and subtracting sign numbers. Find the difference. Use the sign of the greater absolute value. And we get m equal to minus 6. So this one is fair, but some of them are getting a little bit too difficult, and they're out of the question here. And then I'm not going to ask you anything like 37 and so forth. So let me look on down. For the most part, I believe we are done with that. Some of the questions in here are definitely Math 1100 and Math 1150. So I think we're probably going to do, that was problem 28. We're going to start with question number 11, and we're probably going to go as far as, that was 28. You could do 31. So how about this? 11 through 31, the odd and omit 25 and 29. Some of you can do those, but I'm probably wouldn't hold you to that on the main body of the exam. So this was April 6th, and I am looking forward to seeing you. I believe the next time is April 8th. So have a great day, and I'm looking forward to an email or two. I hope you're keeping up, and take care and stay safe. Bye now.